All right, so here we go with how to find the domain and range of a piecewise function. So I've already made a video about how you take a piecewise function, which is something like this, where we figure out what y is depending on what we put in for x. If we put in a number less than 3, we find y by being the x plus 2, all right? And if we put in an x more than or equal to 3, we find the y by this other formula, 7 minus 2x, okay? All right, so yeah, that much I've already talked about, so, but I'll do a recap. If I was going to graph this, I would need points because the graph is made of points, okay? And points are just x's and y's that work out of the function. That's what a function is. You put x in, you get y back out, all according to what the formula is. So for this one, x less than 3. So what numbers could we put in? So 3, 2, 1, 0. Those are all less than 3. And then I put them in x plus 2, and I get 5, 4, 3, and 2. So, okay, that's what I get for this first table. Wait a second, that's x less than 3. I put 3 in. Is 3 less than 3? 3 is not less than 3. I'm really not supposed to put 3 in, so that point will be open. You might say, why do I put 3 in if I'm not supposed to? Well, what's like the first number less than 3? 2.9, 2.99, 2. You get the idea. Rather than put some crazy decimal in, I'll put 3 in and just say, well, that point I'll actually have to leave off, okay? Okay, now this other x is greater than or equal to 3, I put in there, and I get these points, all right? That's how it works. Now, those are the points. The graph is made from the points. So if I plot those points, I'll get like this much. But it continues, all right? Like, look at these. Here's 3, 5. See, that's open right there? 3, 5 is open. It's not really on the graph. 2, 4 right there. 1, 3 right there. 0, 2 right there. Does it continue? Well, if, it's reasonable to believe. I mean, let's try. So -1. What's then if we keep going? -1. -1 plus 2. That's 1. Okay, so you get -1, 1. Yeah, so it's going to keep going is my point, all right? So I plotted the points I had, but I know that I could keep going, right? This goes forever. Numbers go forever. Same thing with this. Like, there's those 3 points on the table, but I would believe they keep going. I mean, if you don't believe it, put 6 in, put 7 in, put 8 in. It will keep going off in this direction. Okay. So here's the question that I made the video about. If this is what the graph looks like, what is the domain and range? Okay, so let me remind you a little bit about what that means. The domain is all the possible values of x, everything that x can be. And the range is all the possible values of y, everything that the y can be. All right, so let's see. What can x be? X can be -3, 2, 1, 0. It could be 4 and 5, right? You get the idea. But couldn't it be anything in between those numbers? Yeah. Couldn't it be anything over here? Like, see this point right there? What's the x coordinate of that point? It's -1, 2. It's -3. And you see this point right here? That's -4. Do you see this point right here? It's like 3.5, right? So anything along there. So the x can be, I guess one way to look at it is the span of the graph on the x-axis. X can be any of these numbers, not just the ones on the table. Anywhere you can point to on the graph, there's a point there that has an x coordinate. So like any of these numbers are possible. And this goes forever, right? So anything is possible over there. And then you got this one. You got this one. You see all these. X can be anything. All right? So here's our domain. All right, we'll say X can be anything. And I'll write that in a slightly different way here in a second. All right, but the x can be any number. Any number is possible. All right, now we can also tell that from this. If you take all the numbers less than 3 and you combine it with all the numbers that are 3 or more, that is every single number. You can put every single number you want somewhere into this formula and get a point somewhere on that graph. All right, so what about the range then? The range is anything the y can be. Now this time there will be some restrictions. Can y be anything? Like y can be, let's see, what's that number? Y can be 4. Okay. Y can be 3. Okay, you get the idea. Y can be 2. Can y be 7? Well, there's nothing up there. The graph doesn't go that high. So you could think of it like this. The range is the span of the graph along the y-axis. That's anything that y can be. So I see like this graph spans the y-axis from here down. All right. So let's say like this. Y can be, where's that open point? Let's see, 3 for x, 5 for y. So that's at 5 right there. Okay. So anything below 5. Okay, so I'll say y is less than 5. All right. Okay, why not less than or equal to? Why didn't I say that y could be 5? Well, that point's open. You know, we put this in that formula, but I told you why we needed that point to be open. So if you don't, it doesn't make it up to 5. Doesn't get all the way up there to 5. It'll get as close as you can think of to it, but it won't get there. All right. Okay, so my domain is x can be anything. And my range is that the y can be anything less than 5. That's how I'm reading that. Y can be anything less than 5. Now, we need to talk a little bit about interval notation because this is not normally the way that people write this when they're doing math. I wrote this in a way that hopefully you understand, but it's not really what I need to show you. I need to show you something else. I need to show you something called interval notation. Now, I made another video that addressed interval notation, but I thought I'd talk about it here since it's relevant. All the videos I posted, I labeled them with the topics that they cover, so you can find the one on interval notation. But every inequality maps over to an interval, or is the same as an interval. For example, if I say x is greater than -4 and also less than or equal to 1, that's an inequality. In interval notation, we would say parentheses -4, comma 1 bracket. All right? The parentheses means I'm not including the 4. If x is greater than 4, 4 is not part of the numbers we're talking about. That's what the parentheses means. So the parentheses is associated with less than or greater than. The bracket means I'm including the 1. If I say x is less than or equal to 1, 1 is part of that. So the bracket is including it. The bracket is associated with greater than or equal to or less than or equal to. Okay? But the parentheses means I'm not including this number, and the bracket means I am including that one. So x can be anywhere between -4 to 1, including the 1, and interval notation is like that. A few more examples. What if I just said x was less than or equal to 1? All the numbers x could be anything less than or equal to 1. That would be anything less than 1. Well, how far do the numbers go less than 1? 0, -1, -2, to negative infinity, right? There's no, if you look at all the numbers less than 1, that never ends. The negative numbers are that way, so negative infinity is like all the way that way. So x is less than or equal to 1 will be parentheses negative infinity, comma 1 bracket. We're including the 1, all right? Okay, we always put a parentheses on infinity. The reason is, well, infinity is not actually a number. It just expresses the idea that we're going all the way to the left. Like if you had the number line, then here's 1. And if you went forever that way, you would go to positive infinity. And if you went forever this way, you would go to negative infinity. Okay? You never get there, though. I mean, you can't go forever anywhere, all right? So we're talking about this, negative infinity to 1. All right, so that's the interval. This is the inequality. One more. X is greater than 10 is the same as parentheses 10 comma infinity. If this was 10, all right, if that was the number line, that's 10, I'd say, well, where are all the numbers greater than 10? They're out there, so they're from 10 to infinity, okay? The inequalities always look the same as the number line. We read it left to right, negative infinity to 1, and 10 to infinity. It's always how we write the inequalities. It's in the same arrangement as the number line. Okay, why the parentheses? Well, if I say x is greater than 10, 10's not part of my answer, all right? Okay, but I said that parentheses would be associated with less than or greater than, and brackets would be associated with less than or equal to or greater than or equal to. Okay, so that's a little bit about interval notation. So let's see. How can we write this in interval notation? Because that's the way that we're going to have to learn to do it. The domain is that x can be anything. That's true about the domain. That would be a correct statement about it. But in interval notation, that would be, well, anything would be the entire number line. Isn't the entire number line, like every single number, negative infinity to infinity? Yes, it is. So that's the domain. What's the range? How do you write that you want all the numbers less than 5? Then you say negative infinity 5, and you put a parentheses. Okay? All right. Now to say we want y, or y can be anything less than 5 with the inequality, it's the same as that interval, but we'll have to learn to use the intervals. That's part of learning what we do. Okay, so there's my domain and range. Those will be my final answers that I'll give for you. Informally, I wrote these other things, but those are the final answers. So when you do your assignment, it says write your answer in interval notation. Now you know what I mean by that, okay? Let's look at one more example, okay? So say we have this function. Here's another piecewise function. Again, I make some tables. I make tables to get points. Points are x's and y's. And points make the graph, all right? Okay, so I say, well, part of this is that if x is less than or equal to negative 2, I put it in there, and that's how I get y. So I did negative 2, negative 3, negative 4. And I could keep going if I wanted to, but I think this is enough. This other one, if x is more than negative 2, you plug it in there, and you get y. So if x is greater than negative 2, it goes in this formula, y equals x minus 3, and I get my x's and y's for that. Greater than negative 2, so negative 2, negative 1, 0. And again, oh, I put negative 2. Am I supposed to do that? If it says x has to be more than negative 2, would I be following the instructions if I plugged in negative 2? Is negative 2 more than negative 2? No, I'm not supposed to put that number in. But I do it anyway because it's a nice round number. But I make a note to myself, I got to leave that open on the graph. If I take these points and I plot them, I'll get this. If you would find more points than me, you would find maybe that point and that point, or this point and this. You get the idea. It's going to go forever like that, forever like this. Okay? All right. Now, so I had my function. I made the tables. From the points on the tables, I draw the graph. Okay? What's the domain and range? Now, this time again, I think the domain can be anything. X can be any number. Can x be this number right here? Yep, there's a point on the graph that has that value of x. Can x be this number right here? Well, like this graph does continue, right? Yeah, there's a point. You know, any number you give me for x, I can say there's a point on this graph that has that x. This graph spans the entire x-axis, okay? Because now what is the domain? All possible values of x. Any number you give me for x, there is some point on the graph that has that x. So x can be anything, negative infinity to infinity. Another way to think about it is that this graph spans the entire x-axis. All right? There's no part of the x-axis that's unreached by the graph. What about the range, though? So that's what y can be. All right? The range is all the possibilities for y. And I would say, well, if this goes forever down, and they overlap each other here, and this goes forever up, y can be any number. You know, is there a point on the graph with y being this number? Yeah, right there. Is there a point on the graph with y being this number? Yeah, right over here. Is there a point on the graph with y being this number? Actually, here and here. So yes, y can be anything. All right? It spans vertically the entire y-axis. Goes forever up, forever down. It spans the entire y-axis. So y can be anything. Also in interval notation is this. Okay, so that's how we look at the domain and range of a piecewise function. In another video, I went into some more detail about how you draw the graph of a piecewise function. Okay, so you can check that video out for more details on that. And then also in another video on the list is interval notation. So if you wanted to see more examples of interval notation, that video is labeled. They're all labeled with the topics they cover. So you can look at that too. Or if you want to request something from me to post to clear anything up, I can also do that.